So by the end of this lesson, you'll be able to describe what factors determine how much air resistance an object experiences, and also describe and calculate situations in which an object reaches terminal velocity. All right. To answer this question, what two factors determine how much air resistance an object experiences? I want you to draw from your experience of sticking your hand out of the car window. Okay. What's going to give your hand more air resistance at certain times versus other times? Like, is it a constant force of air resistance, or can you change it? You can change it. One way you could change it. You can orient your hand. Okay. So we're going to call that surface area. Like here, the air molecules are just hitting this part versus hitting this. There's more air resistance in that arrangement than this arrangement. Good with that? I'm just looking for two. That's the first one. The second one is, what could you do to increase air resistance? Speed. Yep, your speed or your velocity. Okay. As you go faster, what happens to your air resistance? Increases. As you increase the air resistance, as you increase the surface area, what happens to air resistance? Increases as well. Good with that? Okay. Now, terminal velocity. To explain this, we're going to go through a process here. Let's pretend that we are skydiving from a helicopter. Why? Because it just gives us a scenario where we can start at rest. Okay, so initially we jump. What forces are acting on the skydiver? Gravity. Okay, initially we're just going to say just gravity. But let's not ignore air resistance. As the skydiver falls, what happens to their speed? Increases. Therefore, what happens to air resistance? It increases. So initially, like we're starting at rest. As we go faster, air resistance starts becoming a thing. Okay. And as we fall, what happens to our speed? You still have a force of gravity, but you're still speeding up. You okay with that? So what happens to your air resistance? It gets bigger. As you go faster, its air resistance gets more and more. You okay with that? Okay. Will this process go on forever? I mean, yes, I know it stops when she hits the ground, or like when they hit the ground, but like, will air resistance, if they don't hit the ground, continue to increase forever? At what point will it stop increasing? At some point, okay, when your air resistance equals your force of gravity, the sum of the forces is equal to what? 0. And what would happen to your motion? Do you stop? That would be interesting. Like, okay. Yeah. And you fall. How would you describe your motion? Okay. You fall at a constant velocity. And what do we call that constant velocity? Terminal velocity. So terminal velocity is the velocity at which you fall when air resistance is equal to your force of gravity, so that the sum of the forces are equal to 0. Cool with that? Now, do all objects have the same terminal velocity? Nope. So what factors would influence the terminal velocity of an object? Okay, surface area is one. Looking for one other one. Yep, mass. Specifically, I'm going to say the weight. So your force of gravity. Okay. The surface area, and this is why we have a parachute. Does that make sense? Like, you didn't change how much you weigh. You're carrying the parachute on you. The parachute just spread out, and so you have a greater surface area. So the hope is the terminal velocity with the parachute is a whole lot less than you without a parachute. Does that make sense? Okay, you're slowing down. You can also change, like when you're skydiving, you can change your terminal velocity by changing the orientation of your body. Okay, you do a spread X, you maximize your surface area. But if you do a pencil, you just still weigh the same, but you've increased your terminal velocity because you've decreased your surface area. That makes sense? Okay, and then weight. A basketball and a bowling ball are going to have different terminal velocities. The bowling ball weighs more, and so it can plow through the air molecules better than the basketball, so it's going to end up falling faster before it reaches terminal velocity. Okay with that? Okay, so I'm not going to give you any equations for those, but those are like the factors. Good with that? All right. Let's see how this goes. Okay. Everybody good with a brick? Warm-up question. You didn't need to take physics to know this. Brick's going to fall faster. Okay. Here's a better physics question. Talk to your neighbor. Correct answer is? Correct answer is A. Okay. The force of air resistance has to be equal to what when it reaches terminal velocity? Force of gravity, the weight. Which one weighs more? The brick. Go to that. Same scenario. Well, but only after a second. Which one has a greater force of air resistance after 1 second? We're going to assume that the feather has already reached terminal velocity, but the brick has not yet. Here's my recommendation. Look to see what factors influence air resistance. What factors influence air resistance? Not terminal velocity, but air resistance. Talk to your neighbor. Correct answer is A, the brick. What two things is air resistance affected by? Surface area, which has a greater surface area, the brick, and speed. Which one's falling faster? The brick. Good with that? Okay. In this scenario, the next three questions, the skydiver has not yet reached terminal velocity. Okay. She will eventually, but not yet. Have a conversation. Correct answer is? Correct answer is A. Okay, why? Right. It was, we're just speeding up, getting faster and faster. Good with that? Same scenario, different question. What? How would you describe the net force? Have a conversation.
The thing is, I mean, I'll definitely go to find. It's not like it's super campus, right? So I'm sure, but the other thing is, that's what I'm saying. So it's like the sum I don't know how confident. But also, look how like
Correct answer is? What'd you say? Heard B, E, heard bountiful buffaloes and educated elephants. Exactly. Interesting. Okay. As she falls, air resistance. So force of gravity stays constant, but air resistance increases. So your net force is doing what? Is decreasing. Probably shouldn't draw an arrow. That would get a little confusing. Decreasing the net force. You okay with that? Okay, because force of air resistance is becoming more and more in the opposite direction of force of gravity. Okay. Same scenario. The magnitude of acceleration. Thumbs up when you have a guess. Have a conversation. Tell them why you think so. Correct answer is I heard some C's, I heard some E's. Cats and elephants. Interesting. All right, so here's my hint. Is that support or go against your answer? What do we say here? The net force decreases. Is her mass changing? Nope. So the net force causes acceleration. So as the net force decreases, so does acceleration. What does that look like in terms of motion? She is speeding up at a decreasing rate. Her speedometer looks like this. She's getting faster, but she's getting faster slower. You okay with that? Okay. Here's another way to think of it. Initially, when she first jumps out of the airplane, assuming she started at rest, what's her acceleration? 9.8 meters per second squared downward. Right? She's in free fall. Once she reaches terminal velocity, what's her acceleration? 0. So it's going from 9.8 meters per second squared to 0, decreasing the whole time. Good with that? Okay. Guess here's a quick little follow-up. When her parachute is pulled, what does that do in terms of forces? Like, while it's like, is air resistance more or less the same as her weight? If it's less, then she's still speeding up. To make her slow down, air resistance is more. But then she ends up slowing down. I mean, that's what ultimately we're trying to do, right? It's like slow down your motion. You don't want to hit it out of parachute. Like, have you ever seen? I guess another way to look at it: drag racing cars. At the end of the race, yeah, parachutes come out, helps break them, slow them down. Okay, and then once they've slowed down, then that reduces back to how much she weighs, and now you're going at a terminal velocity again, just slower. There's more air resistance. Okay. Right. All right. Got a couple of questions that tie up some loose ends here. Oh, on the review worksheet that's due tomorrow, one of the questions says, what did you learn from a skateboard lab? Scratch that. Think rocket sledder. I replaced that lab with the rocket sledder lab. So, what did you learn from the rocket sledder lab? Okay. What do you think my recommendation is going to be? Set it up. Have a conversation. Tell them why you think so. What do you say? Got some B's. Anything else? Got some D's. Got some butterflies and some dinosaurs. Okay. So one skill that you need to be able to do is be able to rank forces without necessarily knowing much in the way of numbers. So you know that some of the forces are equal to 0 because it's constant velocity. So you have the x component and the y component. You have applied force in the x minus friction is equal to 0. And in the y direction, you have normal force plus applied force in the y direction minus gravity. Force gravity equals 0. So that's your setup. Okay. Once you've got there, you need, this is the skill I'm trying to like, you can look at this and come up with some, you can rank the forces based off of this. Okay, so you know that these two forces are equal to each other. Okay. This green is just a component of the overall force. So you know the overall force is going to be more than the green one. Okay. So your applied force is going to be greater than friction. So B and D are both are stating that. Okay. So what we're having discussions about is in the y direction. Okay. So one way you can do this is to put it all on one side. So you have, sorry, make it all so this everything's positive. So you have normal force plus applied force in the y direction is equal to the force of gravity. So which one's bigger, normal force or gravity? If it's not jumping out at you, right now they're on a teeter-totter and they're balanced. If you took applied force away, took it off the balance beam, not the balance beam, the teeter-totter, seesaw, whatever you called it. Do you guys still play with those? Like, is that a thing in your childhood? Yeah. Okay, I'm just, what's going to happen? Which one's going to be? It's going to go like that. Does that make sense? Because we took a kid off. Okay, force of gravity is more than normal force. 2 plus 3 equals 5. We take 3 off. Good with that? Okay. Correct answer is B. Bountiful buffaloes. Good with that? What's my time? Got one more for you. Last one. What do you think my recommendation is going to be? Ready? Not equal to 0. You have applied force minus force of gravity equals mass times acceleration. You're looking for applied force. Equals mass, 100,000 kilograms, times acceleration, 30, plus 100,000 times 10 for G. Correct answer, D. A very popular wrong answer is C. Like, hey, look, acceleration, mass times acceleration. Ta-da! What you found was the net force. What I was asking for was just one of the forces. Set it up. Everybody getting the memo? Okay. Got a review worksheet due tomorrow.